Hi everyone, welcome back to Mind Over Math. This video is on geometric series. In particular, we're doing the finite sum. There's part 2 to follow. This section is on geometric sequences and series. And first we're going to start with the geometric mean. Remember, the mean is part of a proportion. It is the diagonal in the middle. In our case, this simplifies to using a formula, which is the square root of a times b. In this case, we have two terms, 16 and 25. The geometric mean comes from multiplying them together and then finding the square root. In this case, 40. Next, we want to go to geometric series. We just did geometric sequences where we used comma after each term, and we found that there was a common r. We divided one term by the term in front of it. Now we move to adding those terms up. This is called a partial sum of a geometric series. And this is called S sub n. N stands for the last term you want to add up to. And this is actually the formula, and we're going to use this one right at the bottom here. This is how it's derived. So here's my geometric series formula, the finite formula. That is, it ends at a certain term. So it's called a partial sum. Partial sum means you're not adding up an infinite sum, just a part of them. So whatever n is, the formula is the first term, a sub 1, times parentheses 1 minus r, that's the common ratio, to the n power, it's the same n as over here, divided by 1 minus r. R cannot be 0, and r is the common ratio. Practice that. Here is a geometric series with a pattern, common ratio, of 2. Now you can practice that up here with 16. 16 divided by 8 is 2. We plug this in using a sub 1, which is 1, r, which we just found was 2, and n, we want to know the sum to the 8th term. So we write our formula out, called the partial sum formula for geometric series. And we plug in the numbers. We plug 1 in, we plug 2 in for r, and we plug 8 in for n. So S sub 8, this is what it would look like with the r and the n plugged in. This gives me 1 minus 256, which is actually a negative 255, divided by a negative 1 is 255. It's kind of nice because you don't even need to know the 8th term. All you need to know is the first term, the ratio, and determine which one you'd like to find. Another way to write this, rather than just S sub n, is our sigma notation. We've used this before. Sigma means sum of the series, and this is the lower limit 1 and the upper limit 6. That's actually 1 through 6. So first of all, we must determine the first term. So we plug a 1 in here. We get 1 minus 1 is 0. Anything with 0 power is 1. We find S sub 6, the sum, by using this same formula for the finite sum. We plug our numbers in. A is 1, r is a half, s is 6. Notice 1 minus 1/64 is really 63/64 divided by 2, which would give us actually 63 over 64. And of course, we'd want to take that, divide that by a half, which means turn it over and multiply it by a 2 over 1. And this 2 will cancel with the 64 and give us 32. So our answer in fractions would be 63 over 32. As an improper fraction, that would be 1 and 31 32nds. Now, if we did this as a decimal, our answer would be 1.97. We can do that again. Notice my sum here is 1 over 2. My ratio is 1 over 2, which is 1/2. You can see every term's being taken times 1/2, but divide any term by the previous term. We know the first term is 2. We want to find the sum of the sixth term. Substituting those in, we get all of this on top is over 64 right here, and then this is over a half. Actually, this is over 64. And this gives us 63 over 16. That would be the sum of the first 6 terms. Kind of nice. We don't have to know the first 6 terms. Okay, I like to use this one again because it gives us the rule of a sequence, asks us to find the sum. That's what sigma means. Gives us the lower number 1 to the 6th term. So we got to find the first term, which turns out to be -3. And then we're ready to find the sum of the first six terms. So plugging in a 6 here and here, the ratio is 2. We get -63 over -1 times -3, which is -169. That tells me that the sum of the first 6 terms, all of them being negative, is -189. So here's an application. An online video game tournament begins with 1,024 players. 4 players play in each game, and in each game only the winner advances to the next round. How many games must be played to determine the winner? So we're first going to write a sequence, write it out our givens. And we know by the final round, there's 1 game left. So we put a 1 here. 265 is the first number of games played because there's 4 in each group. So 1,024 divided by 4, let's go back. 1,024 players, that means on the first round, this is divided by 4. That's 256, and only 1 in 4 wins. So then we end up with 1. We end up with the final game here. How many games must be played? So we notice here that 1 over 256 can be put in a base 4, 1 over 4 to the 4th, 1/4 to the 4th, and since the bases are equal, you set the exponents equal to each other, This was an old exponent rule from a logarithm chapter. Add 1 to both sides, and n is 5. So this gives us an idea about how to do the finite sum, and the next video that'll be done will be on the infinite sum. Let's finish this problem up. The fifth round there will be 341 games, because each time, there was 4 people playing. So that means there will be 341 games. So we back substitute that in to find out the total. And that would give us the number of rounds. All right, hope this helps. This is the finite geometric sum. Go on to part 2 for the infinite geometric sum. In the upper right-hand corner, make sure you subscribe. In the upper left-hand corner, make sure you check out other videos. Likes are below, and make comments on topics you need.